All right. So I would like to tell you about Nectree, which is based on research done here. And the mission of Nectree is to dramatically streamline the process of building and maintaining custom enterprise software, which has been a pretty expensive and complicated business in general. We know that there are these newfangled approaches associated with buzzwords like vibe coding, where suddenly anyone can build an application by just making requests in English to a large language model. And you can iterate a bunch of times complaining about things and having your code get fixed. And in the end, you may have built something that almost works. But the problem is if you're in a situation where almost isn't good enough. You could always fall back on the traditional way of hiring a bunch of expensive software engineers to slowly build the thing that you want. That has the obvious downsides from the words that I just used. But what if we wanted to find a middle ground that combines some of the most attractive properties of both of these approaches? That's what Nectree is trying to realize. So in general, we allow an AI-based, rapid, no-code required workflow to develop a piece of enterprise software, but the program that comes out is, for a variety of reasons, quite trustworthy and effective in general, thanks to the interesting research ideas that we're using under the hood. So let me make this a little more concrete now. I want to switch to showing you a pre-recorded video, but it's really our product in action, and I'll narrate it here. I want to make this full screen. Okay. So what we're seeing here is the development environment of Nectree. And on the left is a preview of a currently blank software application that we're designing, and around it are a bunch of features that we're going to use to build the application. So in this familiar chatbot kind of interface, I'm going to type a request now. I want to create an app for CSAIL alliances to track member companies and their research interests. And then we're going to let the AI think about what I might have meant more specifically by that. So far, this is going to be a familiar experience from a variety of vibe coding tools. We'll get to the twist after a few minutes, after we've built out some functionality. So some English text came back summarizing, OK, I'm going to make a few tables of data, and I'll display this one here and this one here. And we get all this interface looking at a page for maintaining a list of companies that belong to CSAIL alliances. We've got another page or sub-page for maintaining a list of research interests that various companies might have, and so on. Seems to have basically worked. That's good. Already more than we necessarily expect from the typical vibe coding experience. But to make it more concrete, I clicked the Fill Sample Data button, and a bunch of fake companies popped into here. Nothing about this was built into the platform. This is just the LLM's knowledge about general domains. We've got a bunch of fake research interests, and some links between companies and their research interests have also been invented. So this is a great start. And let's see what I'm going to try next in this video. We're going to ask for something new now. So my next request is that the table that it invented for linking companies to their research interests is a little too complicated. It has a kind of superfluous column called a link ID. And I say, that seems superfluous. Please remove it. And the AI sort of churns thinking about that. And it's going to come back with a modification. There's some English text summarizing what it did. But most importantly, we click back over here. Cool, that superfluous column is gone. We don't have to be bothered by that anymore. So now I think I'm about ready to start building out some additional functionality in this application. So I asked for a graph of all these research interests by their popularity. AI thinks about that for a bit. And we should shortly have a graph in front of us. Let's see where that popped up. Yeah, simple bar graph listing the research interests. AI is number one, obviously. Somehow it's tied with sustainable agriculture. Guess it doesn't quite understand the domain perfectly for generating sample data, but I think that's OK. We basically got what we were looking for. And let's now be a little more ambitious and try to get some more functionality to pop out here. So my next request is going to be add another useful graph. And I've left it as open-ended as that. And we'll see what the AI is able to come up with just based on general domain knowledge and the structure of the application as constructed so far. I made up a graph that groups active companies by their statuses, which ones have been approved for membership, which ones are still being reviewed as potential members, and we get a nice pie chart showing all that. Though it's a little hard to take it all in because this is so big And I think we can improve the aesthetics of this page a bit, so I'm just going to make a request about that. I'm going to ask, make the graphs side by side instead of one on top of the other. So move to a horizontal layout instead of a vertical layout. And we can put in that request, and in a moment we should see it has been brought to life. Great, so here's our new layout, and now let's say I'm happy with this version. So a few other the features of our platform I want to show. So far this is sort of like an unusually lucky traditional vibe coding session that things just kind of worked without having to look at code. But one thing is, at every step of this process, this isn't just a preview or a mock-up. This is a real production-ready web application that's been running the whole time. And you can send a link to people, and they just start using it, and everything's great. But also, how do we know that we got what we wanted in the end? For one thing, we can view the schema of the database that we've implicitly designed through this interaction, a list of tables with their columns, and the types of data that are found in those columns. That's nice and concrete. But more interestingly, we get this kind of narrative outline of all the functionality in the application. So up at the top, we see there's a page called main, and then within it, there's a tab called companies that I might switch to or not. And then within that, we have what's called an approval flow table. That's actually a reference to a reusable software component from our library, which we connect to the company table, and we explain a little bit how to map the terminology of that library component onto our particular database schema. And we can drill down in some parts by clicking to get more details on column level handling of different parts of that data table. And scroll down to the bottom, we can find here are our graphs. We've got a bar graph, we've got a pie graph. We can click to expand. There's actually an SQL query behind each of those. We'll probably find a nicer way to present the SQL for people who aren't used to reading that language. But the point is, all of this is totally unambiguous. This text was not built by an AI. It's actually created in a deterministic way from a program in our new language that has, behind the scenes, been being filled in as we go through the process of explaining what we want and gradually developing this application. And this English rendering of that program can be read by people who don't speak code, but if they do want to see the code, got something like this too. It includes the database schema and basically exactly the same content I was just showing you, just laid out in a code-style text file instead of as an English outline. So this is deterministically transformed into a deployment-ready application using relatively old-school programming languages and compilers technology, whereas people who are not comfortable with code can read the version that was turned into English. They can find any issues on their own with no need to test the application to be sure they found every possible bad thing that can happen. Fix it at this level by asking requests in English, and then you can truly responsibly deploy a solution that was built with these tools. I'm going to switch back to slides here. OK, so only had time to show you a sliver of what's possible in this platform. We can handle all the other general features you'd expect for serious enterprise software. We can connect all of your external databases and services like ERP platforms or even your own custom web services. We can do authentication and access control. You can plug your company's standard single sign-on system into this platform, use it to control who's allowed to view which pages or which parts of those pages. You can create different pages within the application, say one for each department of a company that's supposed to be involved in a solution. So in short, it's ready for all the canonical examples of enterprise software development. So let me tell you a bit about my experience and how it leads to the particular way all this works under the hood. So here's first a shocker I'd like to share with you all. There are fields besides artificial intelligence within computer science that are making interesting progress. And I work at the intersection of three that are shown in this handy Venn diagram: programming languages, compilers, and formal verification. The last one being maybe the most niche or little known one that has to do with mathematical proof of the correctness of programs. In the middle, intersecting all three, is a new programming language called Web that I started developing when I was a graduate student. And it's a domain-specific language for building full-stack web applications with some interesting guarantees about the proper functioning of all the programs that you write. And the way that I came to be developing UrWeb is in high school, I had a formative summer internship at a company doing contract enterprise software development for e-commerce websites. Learned all about SQL databases and GUIs that we build on top of them. And as I progressed through my career in higher education, I started realizing that there were ideas out there that could help achieve a really high level of confidence that the programs we write are correct, not just relying on testing and other less reliable methods. So I came to specialize in formal mathematical proofs of the correctness of programs. And then at some point I realized there seemed to be essentially no one else in the world thinking simultaneously about both of these topics, enterprise software and mathematical proofs of correctness. And I realized there was a great opportunity to design a programming language that brought ideas from the world of computer theorem proving into streamlining the development of enterprise software. And that language is UrWeb that I just talked about, which, for instance, instead of automating proving a mathematical theorem, can automate writing much of your application for you from a high-level requirements description. The big ideas behind how this all works have to do with inventing a component architecture that lets us create reusable building blocks that together cover most of the functionality we're used to in these kinds of enterprise software programs. So in this component architecture, you can have one piece that encapsulates inside it, like say a Java class for a hash table would encapsulate an array. Instead, we're encapsulating front-end code, back-end code, database code. We're guaranteeing that they hook together correctly. And as you plug together any blocks that each have all these pieces inside of them, all the plumbing between those pieces is also constructed correctly as well. Once you have these blocks, there are all kinds of things you can do. When you have examples like a building block standing for a process of entity resolution, a kind of ETL exercise, porting data from one place to another, we have at least one component in our library for that. You can build components standing for connections to particular external services, like the example of Workday shown here. We can implement all kinds of forms, connect to systems like SAP. And once you have these building blocks, there is then an infinite variety of ways you can plug them together and get all kinds of interesting variations, which then correspond to the different pieces of enterprise software that you can construct out of this one framework. So I'd like to say that the way that our workflow goes is with just enough AI, using AI in the parts that it's a good fit for, kind of brainstorming and ideation, without making AI trusted if you want to be sure you've produced a high-quality, secure piece of software. So the user iterates, talking with the AI in plain English. That process is all about picking the right blocks out of our library, plugging them together in the right way to build the application. Once you're happy with that description, you don't need to use AI anymore. Pass it off to a relatively old-school compiler that does the work of turning your code into a deployment-ready, highly optimized solution. And abstractly, part of the way we do that, when you describe your application by plugging reusable blocks together, that may naturally have a very winding path that your data takes as it flows through the structure of this program that's been nicely broken into pieces. There are performance costs through naively implementing that path in the final application. Our compiler kind of straightens out those paths, blows away the runtime overheads of using an abstract way of describing how the application works. So you kind of get to have your cake and eat it too. A really high-level description written with the help of AI, but in the end, you get really efficient code that most developers you could hire wouldn't even be able to create if you gave them twice as much time as you're used to write it. So overall, we are looking for companies that might like to be design partners with us and apply this technology to create a variety of enterprise software solutions, whether it's internal tools, solutions that also connect to customers or vendors, etc. Cases where every company builds its own version of the same solution. They're all a little different, but those small differences bring a lot of value. That is the kind of scenario that Nectri is really fine-tuned to handling. And unfortunately, I'm going to need to go teach at exactly the time the next networking break starts. But I'd like to point out Marco, one of our team members over there, who would be great to bring questions to, as well as emailing me at the address shown on the screen here. And I've been told we're not doing Q&A sessions for this part, so I think I'll thank you and walk off the stage.